Hi, I'm Dalibor, and for the past 12 years I've been reviving manufacturing of Nixie Tubes. Currently I'm researching a new Nixie Tube model, and for this new model I need to find out how to produce a critical component that is called button stem. So this video is going to be about the button stems, or the attempts to make a button stem. But before we dive into this, I want to show you how I imagine that the F Nixie tube will look like. So here we have two old Nixie tubes manufactured in the heydays of Nixie tube production in the 1970s. This one is the famous large Z568M Nixie tube manufactured in Berlin in East Germany, and this one is Tesla ZM1042 manufactured in former Czechoslovakia, now the Czech Republic. I personally find the ZM1042 the best looking Nixie tube ever. It has beautiful proportions, beautiful font, it has nice clean round top without the remainings of the pumping tube which is in the bottom. It's really a nice looking tube, but if I could make one small change into it, I would make it a little bigger. 2 weeks ago a very rare tube appeared on eBay for sale. It's this F9090AA produced by CSF in France. This tube is almost exactly as I imagined the F Nixie tube to be, with just very small details like the exhaust port here on the top. I think a tube like this will still be visible across the whole room if you have it on the shelf, but it will not be as large as the 568M that would prevent you from placing it on a working desk, because a tube made of 6 Nixie tubes like this, it's really large. And if we want to succeed with a series production of the F tube, we need to put all focus on only one Nixie tube, and we have to come up with something which is universal for all possible uses. So in the last video I prepared the molds for making the stems, and then I wanted to make something quick, some tests, so I placed the pins into the molds, and because I didn't have correct diameter of glass, I crushed the glass tubing that I had and put the glass shards into the mold. That didn't work, that was expected. I found first few problems. The tolerances that I used for positioning the molds over each other were too tight, so I had to file a little bit the diameter of the internal of the lower mold so that the upper mold can slide over it. And I also had to remove the locating pin because it was jamming completely in the hole. As it heated up with the flames, it was bigger than the hole itself, so the mold couldn't slide into it. After these changes I decided not to use pins yet, and I used just glass, so I cut the glass tubing to rings and heated up the rings and tried to make the stems. It was better than last time with the simple test mold made of steel. This time the glass was flowing better into the sides of the mold and making really nice shape, but the problem was that in most of the attempts the glass was sticking and jamming in the upper mold. So these are the problems that need to be addressed. As a first solution, I will add a draft angle in the upper mold. I was talking about this in the previous video and then I forgot to make it. So this is first thing to do, and later we'll do polishing of the mold. Meanwhile, we got glass for the envelopes, for the stems, for the outer ring on the stem, and for the exhaust pipes. We might need to add some more glass to the center of the stem, so we have also slightly smaller diameter tubing here. So now the task is to cut these and try to make another stem. And this is the first attempt with the draft angle finished in the mold. I'm using pins here, and the glass ring is longer than the pins. The volume of this glass ring is the same as the volume of the glass in the finished stem. Because it is longer than the pins, it tends to stick to them while it is collapsing, and that leaves a glassy layer on the pins. Once the stem is finished, we need to clean the pins so that we can spot well the contacts, like the digits to it, and this glassy layer would make it super difficult to clean. Another problem that happens is that the glass is flowing through the gap between the upper and lower mold. This is the place where we made the draft angle. This is something we will have to solve, because once the glass gets to the gap, it prevents the upper mold from getting and reaching to the bottom in the next pressing. Another valuable lesson is that I have to extract the stem from the mold while it is still hot. I must not wait until it is cool, because otherwise it sticks to the mold, or maybe the pins are stuck in the holes and it just can't be extracted once it is cold. In the next attempt I used shorter glass ring that was just a little bit higher than the pins, and it collapsed pretty well around the pins, and after pressing it surrounded the pins very well. And this time I remembered to extract the stem while the glass was still hot, and it went out very easy. It seems that a little bit more heat would help, so I will try a new burner with 2 nozzles. The previous attempts produced stems with a hole inside, with not enough glass in the center part of the stem. And so for the next stems I thought maybe using the smaller diameter glass ring to add additional glass might help. The outer ring melted like in the previous attempts, but the central ring was difficult to get into the molten state. When I pointed the burners there, the pins were easily overheated and they started to spark metal. I tried to reheat it several times, and the same problem with the glass flowing over the edge of the lower mold appeared, so the glass again got into this gap between the molds. And in the end I tried to use the full power of the burners on the stem, and the pins completely melted away, so produced stem like this. So that's the development on the stems that I made in the past few weeks. There is definitely a progress. It starts to resemble a stem. As usual, the more I'm into it, the more I see that the path to the fully working stem will be longer than I imagined at the beginning. The ability to make a stem for a Nixie tube is the last piece in the whole picture of a Nixie tube, of the F model Nixie tube that I talked about. It's the only element that is missing. And at the same time, if we manage to master this production of the stems, it will bring a significant advantage to our business of the production of the Nixie tubes, because we will have the stem production under our control, and it will create a long-term advantage. We'll be able to control the quality and we'll be able to reach reasonable price. There is of course the possibility to find a supplier, but I see it as a shortcut because this is a very niche product. The remaining producers either supply very specific businesses like photomultiplier tubes, and so these are expensive tubes usually made from cover glass. The stems cost something like $10, $15, $20 or 20 euros per piece, and this is too high for us, and also it's unpredictable. Such a supplier can anytime end the production, they can move to something else. Imagine that we build a factory for the Nixie tube production, that we really reach the quantity of 20,000 Nixie tubes per year, and then at some point the supplier will go out of business, or they will just change something and we will not be able to get the stems from them anymore. So for this reason I really want to have this under control, because it's a critical component, and I want to be able to produce them in-house. There are other technologies that we will use, like stamping or etching digits from a sheet of metal and so on, and these are all technologies that are used in millions of other businesses. The industry is large, so these are things that I will feel free to outsource and purchase from third-party suppliers. But these very specific things to the tube production I want to have under our control. So what will be next for the development, for the next iteration of the mold? The problems that we have right now is the gap between the upper mold and the lower mold. There is a gap where the glass is flowing inside, so we will need to machine a new upper mold with proper draft angle, but without this gap. Another problem is that the glass, which is on the bottom of the stem, is not heated properly. It's still kind of solid and it doesn't flow as it should. So it creates wrinkles on the bottom of the stem. So we need to find a way how to heat the glass properly. I'm now using two nozzles, two burners, instead of one, which I used at the first attempts. So maybe adding another one might help. I need to experiment with the burners, but you see that if I heat it too much, then pins get melted away. So I will need to switch to higher quantity of smaller burners so that the glass is heated in proper positions and not with just two large burners like now. So I mentioned a number 20,000 tubes per year. Why this number I will discuss later. From the calculations that I did, it's a optimal number for us how to reach a quality tube, consistent production, and a reasonable price of the production. Of course, for this quantity, we will need to increase productivity on every single manufacturing step, like pumping, washing, like everything. But every single production step we can do in a small, even unproductive, but small quantity, like we do it for the R tube, with the exception of the stems. So how I plan to produce the stems at this quantity? we will need, let's say, 30,000 stems per year. That's more than 100 stems made per working day. And this quantity will not be possible to produce on a lathe like I do now. I do the prototyping. So the vision is that at first I will make quickly and cheaply a prototype of the stem. I want to go through all the processes. I want to learn how to press it, where the glass needs to be, how the molds should be shaped, how I need to heat the glass in order to get a fully working and reliable glass to metal seal on the pins. At the lathe, I want to produce some, let's say, few tens, maybe few hundred stems to really get the feeling for production of the stem. And once I have this, I want to start building a machine that will be able to reach higher productivity. So in the old movies that are on YouTube from the Mullard factory or Philips factory, you can see that they have a carousel machines. So this is one way how to make stems. These machines had productivity of some 450 stems per hour. In just a couple of hours or a couple of days, we would be able to produce stems for the whole year of production. So at first I thought that this is overkill to build such a complicated machine for us. And I was thinking, let's make a single position machine that would be perfectly aligned, all the mechanical movements would be aligned, and there will be flames and all the burners, feeder, extractor, and all these machines would be automated, so that the machine would be not as productive as the carousel, but it would be fully automatic, and it would be easier to build. Because building the carousel machine with all the 24 positions and these tens of burners and individual presses, and this seems to be a bit too challenging. But now I'm not sure, because again the YouTube show its power, and one of the old friends, Jerome from Holland, who is interested in CRT production, so he is developing in his shed in Holland near Eindhoven, where Philips was based some decades ago. Jerome found some papers that came from RCA Factory, from the RCA Corporation from United States, and these are full description, like a full process description of the stem manufacture on the carousel, so including all the flame settings, glass temperature settings, like every position from all these 24 positions along the carousel is fully documented with A4 full of text and everything. So this is so valuable information. So maybe it's easier to build a carousel with all this information that we have about its operation than trying to build a machine that was never actually built before. So in short, each of these two approaches have their own pitfalls. The carousel is super complicated. As for the quantity of the parts, the movements, the mechanical side is definitely more challenging. But we have the operational manual, and the single position machine would be less productive, less moving parts. It would be simpler to make, but we could end up in problems that were never experienced, and we would not know how to solve them. Anyway, the general idea is that on the glass lathe we will first prototype the production to the step where we are able to produce the fully working stems for the production, for the prototyping of the F-tube. And once we have all the information how to produce the stems, we will start searching for ways to produce the stems more productively with building either the carousel or the single position machine.
Máte případ?
Pokud jde o paranormálno, jde o obor vědeckého zájmu, ne o obor státní bezpečnosti.
Děs, jak nás dokážou oklamat vlastní smysly.
A year ago, we were asked by a production company called Barletta to make 3 clocks for their TV series that they are producing in a cooperation with Czech TV and also German ZDF. The name of this TV series is We Are On It, Comrades. In Czech it's To se vysvětlí, soudruzi. And it's happening in 1980s, and it's about an institution that is investigating paranormal activities. So quite fun thing, and it was a great chance to produce something different for this series. So one of the clocks was our standard 4-tube Puri clock in silver. It matched the surroundings quite well. The other clock was built also on the electronics of the Puri clock, but it came with a wooden stand, with a wooden base. We've got a block of red exotic wood and cut it on the CNC router, and it came pretty well. The third clock finally was built around the IN12, and here we did a completely crazy experiment. We asked Midjourney to design a Nixie clock. We let it generate roughly 50 designs, took 5 of them, and let the Barletta company pick one, and this one was then made in physical clock. The first 3 episodes were already broadcasted at Czech TV, and you can see them at the TV website. I shared a link at the description under the video, and there are 5 more episodes coming, 1 episode every Sunday. Another 4th episode is coming this Sunday at 8 o'clock European time, so Prague time. So you can watch it. Sadly, it has only Czech subtitles, so it's mostly for Czech and Slovak people. At least you can scroll through the video and try to find the clocks. Already at the first episode, all 3 of them appeared. The TV show is planned to be broadcast in Germany as well at the TV ZDF. It should start from September, and hopefully this will open the TV show to more viewers in more languages. Thank you very much for watching, for your attention. I very much appreciate all the ideas in the comments. They are very important. In the next video, I want to focus on machining the upper mold from scratch. I want to make it correctly with the draft angle, but without the gap where the glass is flowing. And we'll also focus on correct heating of the glass so that it flows correctly, because right now we have cold glass on the bottom of the bottom stem. So thank you for watching.